So with the SBS-6500 unit, the unit was developed to do or handle a lot of the functions that the other internal resistance testers on the market can't do. And we accomplish this by our configuration of our memory and our file storage so that we can literally track the lives of our batteries across their entire life without ever having to go back in and reprogram or delete information off the unit. The unit will actually record up to 20 years worth of maintenance data without having to modify anything on the unit once we get it set up to start taking the readings. So the 6500 can store a database of up to 200 separate reference values. So this would be my battery models and manufacturers, and then, you know, all of the alarm thresholds for low voltage, low or high internal resistance, temperature alarms. Those all get set up in that database ahead of time. And then as I set up my strings or my locations that I'm going to be taking measurements at, I just select the appropriate battery installed in that location from that database entry. They can be set up on the unit itself one by one, but it's much easier to connect the unit to the software and enter all my database references all at one time. And then the software updates all that back onto the unit as you make those changes. So if you've got a complete list of all of your different battery types and manufacturers available to you before you start using the 6500, it makes the entire process a lot easier. One of the other nice things that we did about the unit is that you can go back and you can modify or update any of those entries over the life of the unit as well. So if I had a battery installed in a substation, and let's say I didn't know what its reference values were at the time that I went out and took the first set of measurements on it, I can go back and put the correct reference values in at a later date and time, and it'll update all the results that have been taken up to that point. I can make additional entries into that database or into that string list at any time. So from the software or from the unit, I put in a new set of batteries, I can add that set of batteries to the unit without having to delete anything or start over again. And then those existing entries can be edited, and those changes are applied to all the strings that are affected that use those same reference values. In order to use the SBS-6500, we recommend that you install the software prior to using the unit. This lets you go in and it lets you set up those reference database entries and populate the string list. The unit's compatible with all of the Windows platforms. The SBS-6500 connects to the PC with a USB cable. The software is designed to automatically connect to the SBS-6500 unit as soon as it's powered on. And then once that software is up and running, the software actually displays everything that's on the display of the screen of the unit at the same time. So in the software, we've got basically 3 tabs that we work with. We've got a string list tab, and then we have a reference database tab, and finally we have a live monitoring tab. In order to set up a string or a measurement location, I have to have a reference database entry that I can tie that string to. So the first thing is to set up a reference database entry. Hit the reference database tab, I'd enter the battery model, manufacturer, and the type of battery: lead acid, nickel cadmium, nickel metal hydride, lithium ion, some other polymer, or none. And then I'd enter the measurement voltage for that particular battery. So if I've got an individual 2-volt flooded cell, I'd set that at 2 volts. If I had a nickel cadmium battery, I'd set that at 1.2 volts. Whatever the nominal voltage of the block measurement that you're going to be taking is. Low voltage limit, manufacturers usually publish a minimum recommended float voltage for that particular battery model that voltage when the battery is being charged or in float service shouldn't drop below. And that's the value that I enter for low voltage limit. I want to know if any of my batteries aren't charging correctly. On the right-hand side, we have a cells per jar block. So this block is always going to be 1, with the exception of if I'm using the SBS-6000 digital hydrometer to import specific gravity readings from the cells as well. And I have like a 6-volt battery and I'm measuring 6 volts and I'm measuring the internal resistance of that 6-volt block. But then I'm going to go back and I'm going to take 3 specific gravity readings for the 3 cells that are within that block. Then I could put a 3 in this space and it would leave me 2 space holders for those additional specific gravity readings. Otherwise, this block should always be 1 for 2-volt cells or 12-volt valve regulated batteries or any other thing that I'm going to measure. It's only if I need additional specific gravity spaces that I would put something besides 1 in that cell per jar block. Next block is capacity, and this would be the nominal 8-hour battery capacity that's on the battery stenciling or on the label on the battery product itself. And then finally, the impedance value or the reference value of what that battery's internal resistance should be when the battery is brand new. If I don't know that value, I can check the unknown checkbox, and it's going to put placeholders in there to store blanks so that I can come back in the future and put the correct value in there. Once I get all these entries into this table, I simply click add, and it adds that entry into my reference database. Once that database starts to populate, you'll see database entry number 1, number 2, number 3, number 4. I can highlight any of these database entries, and then I can modify those parameters that are inside that entry and hit save. So an example here would be I take that unknown checkbox out, I put in that 1.88 reference value from the manufacturer. When I hit save, it's going to ask me if I want to continue editing that reference, and then it's going to apply that reference value over top of the other strings that are using that as their reference value. So it'll automatically update the results to pass, warning, or fail once I put in what that actual reference value should be. On the string list, this is going to be a list of all of the locations where you're going to be taking measurements. So substation 1 through substation 999. The string list is built 1 entry at a time, simply by entering the name of the location that the measurements are going to be taken at, and then selecting the reference value from the drop-down list next to it. And then just press enter, and it's going to save that entry. So we're going to get out of this quick start guide, and we're going to go over the actual software. And the first thing we've got is we've got a reference database, and this is a list of all of the possible battery model numbers that we have at our different installed locations, and then all the reference values that go along with those. And we're going to come down here to the very bottom. We're at 87 SBS demo, 12 amp hour lead acid, impedance 23 milliohms. This is the reference value we're going to use for the demo today. And I just took a measurement on this battery, and its impedance is actually up around 48. So let's modify that. We'll hit save. And it's going to update that data onto the unit. Once it updates that data, you'll get an audible confirmation, and then we can go over to string list. We're going to add a new measurement location. And for today, we're just going to call it demo 711. That's the 12th, 712. Then we come over to that reference database. We find our reference value that we just entered. And we're going to add that new string into the top of the software. On the unit itself, it's going to set apart memory blocks to record 100 historical readings for that cell. So if I hit view right now, I have no readings. I have never taken a reading for that location. But if I look at the data by pressing the data button on the unit, and then I scroll over to record, and I press down on the rotary key, and then I scroll down to that demo 712. And I go in and look, I'm set up for test number 1, cell number 1 in the string, demo 712, and it's going to allow me to measure up to 250 cells in that first test. But at the same time, it's going to allow me to record up to 100 historical tests on that battery system. So I can literally go to a substation every quarter for 20 years, record all that data, and trend the entire life of the battery system. And this is a feature none of the other units have in their software or in the unit's capabilities. The ohms key takes me back into the ohms measurement mode. And in this mode, right now, you'll see that I'm recording on string 3. It's like test number 1. But we actually want to go in to that string that we just set up to take readings. So once I get my reference database set up and I get my string list set up, I would go out to substation demo 7-12. I'd press the data button. I'd go to record because I'm going to record new readings. I'm going to select that demo 712 from that list. I'm on test number 1, cell number 1, so I simply hit start. And the unit now comes up and it tells me that I'm on string number 6, test number 1, cell number 1. Here's my reference values that the readings are going to be compared to. And I'm ready to take my first measurement. So I just go out to the battery. The unit is an auto recording device, so I connect my positive and negative leads to that very first battery. And I get my voltage, I get my resistance, and I get my temperature of the negative post all within a single reading. As soon as I lift the leads off that battery, those readings stay on the screen until I connect to the next battery. When I get the audible confirmation and the pass, warning, or fail status on the screen, that lets me know I can go on to the next battery in the string and do the test on that. You'll see that the warning goes from small case to uppercase, highlighted, and then back to small case. And that means that the reading has been stored and recorded. And then I can just move on to the next cell. So I can literally test these things at about 3 seconds per cell or 3 seconds per battery, just long enough for the unit to stabilize and grab that reading. Let's say I'm going through my string and all of a sudden I get my leads backwards and I get a bad reading. Here I've got a reverse polarity. It's showing up at minus 12.21 volts. With our unit, I can actually go back into data. I can go back into that data record. I can go back into that demo string. I can go back up 1 space to that recording that's in error. It was recorded at minus 12.2 volts. I can press the start button, and then I can read and record back over top of that previous reading. So now I get a good recorded reading in its place. If I go back in and I look at that data now, you'll see that I got rid of that negative. And now it's got the positive value for that voltage in it. So one of the things I recommend with the 6500 is anytime that I get a warning or a failure, and I'm not expecting that warning or failure, I can always go back and take another reading to verify that that reading is actually a bad reading or a warning reading, rather than just misplacement of the probes or having the wrong polarity or something. So once I get all my readings from my string, reporting on the SBS-6500 becomes very easy. I simply click report. I go to that location that I want to generate a report for. If I have more than one historical test for that string, each one of those tests is going to be listed in that drop-down box. So test 1, test 10, test 56. Since I only have one here, there's nothing there, but I can just hit make a report. And then the SBS-6500 software is going to generate a complete battery condition report for me. And you can see here's the list of the substation. The battery manufacturer is SBS. The model was a demo 12 amp hour. I measured 4 batteries. All 4 of those batteries came up as warnings. It gives me graphical representations. So all 4 of them came up as warnings for being undercharged, but their internal resistance values were within that limit that I set up. If I was using the SBS-2003, I could import the specific gravity readings, and the specific gravity of those cells would show up in this report as well. On the second page and third page of the reports are actually the numerical data for each one of the measurements I've taken. So you can see here's my internal resistance, my voltages, my temperatures, and then the pass, warning, or fail result. This report can be printed directly from the software, or it can be saved to an Excel spreadsheet, a PDF file, or a Word document. So once I start generating reports with the unit, so your quarterly or monthly battery reports are going to come in this format, and it's going to give you as often as you do your maintenance, it's going to give you a battery condition report. It's going to give you the reference values, the measurement voltage, what that low voltage limit was. It's going to give you the number of cells that pass, fall into warning, or fall into failure. And then it's going to give me all the averages. The bar graphs themselves are going to show the plotted trends or differences in voltage between the cells, internal resistance between the cells, and specific gravities. So just some examples of some different reports from different sales orders that we've shipped out. Here's 30 cells. And it's going to track that historical data. Once I get more than one test done, then the software offers me the option of performing charting functions. So if I come down here and I hit chart, I can chart the historical trends of that battery by cell or by string over the life of the battery system as well. And these bar graphs are color coded as well to show the changes from normal readings to warnings to failures. I can look at an individual cell and just look at cell number 1 and chart its history. Or I can look at a particular test and chart that entire test. From here, I can also do a screen capture if I wanted to incorporate that into a report. Just throw that on the desktop. So one of the features we integrated into the 6500 is the SBS-2003 digital hydrometer, and we built in a Bluetooth interface. So taking specific gravity readings, I'd go through the string, I'd take all my resistance readings and voltage readings with the 6500. I'd use the 2003 to take all my specific gravity readings. I'd press this upload button on the front of the SBS-6500. Follow the on-screen instructions for the 2003 to get it into the Bluetooth transmit mode, and then simply hit next in the software. And the SBS-6500 is automatically going to pair with the 2003, grab all those specific gravity readings, and then download them into the SBS-6500 and put in with the battery voltages and internal resistance values that I measured. The SBS-6500 has a couple of additional features to it. The first one is it has a backup and restore feature. So what this does is it backs up your reference database, your string list, and all of your historical measurements. So that if you ever had to send the unit in for repair, if we ever had to replace like a display because it got cracked from a drop, anything like that, we can back up all of the data onto the PC and then load it or restore it back onto the unit. The other nice thing about the backup restore feature is you can do a backup file of your system. You can email me that backup file. I can open it up and we can both be looking at the records on your unit all at the same time. This comes in helpful if you're trying to, one, get your reference values set correctly for all of your measurements, or two, if you're trying to analyze your data and you just need another set of eyes on it. One of the other really nice features of the SBS-6500 is we put in a feature called live monitoring. So if I clear this and reset it, and I get a unit connected to a battery, let's say I've got a battery that comes up as warning or fail. With this unit in live monitoring, I can actually connect the 6500 to that battery, and then I can walk over and I can turn the charger off for 10 or 15 or 20 seconds, and I can see what happens to those internal parameters, how they change as that battery goes under load. And then I can turn the charger back on and I can capture the recovery of that. And again, I can save this or do a screen capture of it out to the desktop. And then I can do that same with the known good battery, and I can make a diagnostic comparison of how a battery that comes up as warning or fail looks compared to a battery that's a known good battery. So this is an internal feature of the SBS-6500. For this feature to work, it does require that the 6500 be connected to the software on the laptop. So the live monitoring feature doesn't work on the 6500 without the laptop connection and the software. All of our screens have all the controls right here on the key panel. So when I'm connected to the software, anything I do in the software actually has the same effect as if I did it on the handheld unit itself. Some of the little tricks, this F4 key, 4 milliohm scale. If I'm doing 2-volt individual cells, I want to put it into that milliohm range so that I don't get overload readings on the scaling of the unit. Just something to remember. We do have a built-in zero adjust. So if I change from the pin probes to a clamp probe, or I change out the probes themselves, I can do this zero adjust procedure. And what it does is it goes back through and it zeroes out the cable resistance for each of the ranges from the unit detection back out to the tips or clamps of the probes themselves. Like I said, the unit records the temperature at the negative post of the battery when it takes its measurements and records them. All of the functions on the unit all have built-in help. So no matter where you're at in the operation of the unit, if I push that help key, it's going to bring me to the help topic for that particular function that I'm doing. And then the menu itself allows things like turning on and off the audible buzzer, adjusting the contrast, formatting date and time, and controlling backlight and automatic power off.